Welcome to qnawire.
Hi, so over here we want to calculate what is going to be the final temperature for the system in which we have added this amount of copper at this initial temperature to 500 grams of water at 25 degrees Celsius. So in this case, what is going to happen is that minus the heat that is going to be provided by the copper is going to be equal to the heat gained by water. So we're going to have minus mass of copper, heat capacity of copper times delta T for copper would be equal to mass of water, heat capacity of water, of H2O, times delta T for H2O. So in this case, the final temperature is going to be the same for both of the systems, for copper and for water. So remembering that delta T is going to be equal to T final minus T initial, this equation is going to become minus mass copper, heat capacity copper, T final copper, plus mass copper, heat capacity of copper, T initial of copper, equal to mass of water, heat capacity of water, final temperature of water, which is the same final temperature, minus mass of water, heat capacity of water, times initial temperature of water. Let's collect all of the terms with final temperature in common on the right hand side of this equation, which are these two terms. We're going to end up with mass water, heat capacity of water, final temperature, plus mass of copper, heat capacity of copper, final temperature, would be equal to mass of copper, heat capacity of copper, initial temperature of copper, plus mass of water, heat capacity of water, initial temperature for water. Now just factorizing the final temperature over here, let me put it in red since this is going to be like an extra step. We can take out the final temperature, factorize it, and solve for this. So the final temperature would be equal to mass copper, heat capacity of copper, initial temperature for copper, plus mass of water, heat capacity of water, times initial temperature for water, divided by mass of water, heat capacity of water, plus mass of copper, heat capacity of copper. So in this case, we need to remember that the heat capacity of copper is going to be equal to 0.382 joules per gram degree Celsius, and the heat capacity for water is going to be equal to 4.184 joule per gram degree Celsius. So replacing the values provided in this question, the final temperature would be equal to mass of copper, which is 383.25 grams, the heat capacity that I just mentioned, 0.3825 joule per gram degree Celsius, times initial temperature for copper, which is going to be 192.54 degrees Celsius, plus mass of water, which was 500 grams, heat capacity of water, 4.184 joule per gram degree Celsius, times the initial temperature for water, which was 25 degrees Celsius, divided by mass of water, 500 grams, times its heat capacity, 4.184 joule per gram degree Celsius, plus mass of copper, 382.25 grams, multiplied by 0.3825 joule per gram degree Celsius. As far as the units, you're going to see that the numerator is going to be in joules, and the denominator is going to be in joule per degree Celsius. So after division, we're going to have our result in in degrees Celsius, and the final temperature is going to be equal to 35.94 degrees Celsius. And with that, it would be all. Thank you very much and have a good one.